August 23, 1879, a fence post snapped clean through on the Miller Ranch, 40 miles east of Cheyenne, Wyoming Territory. The cowboy holding the wire, Cutters watched the tool's handle crack apart in his hands, the iron jaw separating from the wooden grip. He was 3 days into repairing 5 miles of barbed wire fence before winter, and now his only pair of cutting pliers was ruined. The nearest hardware store sat in Cheyenne, a 2-day ride each way. By the time he returned with a replacement, snow would be falling across the high plains, and the fence would remain unfinished. Cattle would wander through the gaps. Neighboring ranchers would complain. The job that should have taken a week would stretch into spring. He looked down at the broken tool, then across the grassland toward the Union Pacific tracks, cutting through the valley below. Sunlight glinted off something metallic near the rails. He mounted his horse and rode down to investigate. Scattered along the roadbed, half buried in gravel and dirt, lay dozens of iron railroad spikes, bent or discarded during track maintenance. He dismounted, picked one up, felt its weight. Solid wrought iron, about 6 inches long, square shaft tapering to a blunt point. He collected a dozen spikes, stuffed them into his saddlebag, and rode back to the ranch house where a small forge sat behind the barn. By 1879, 10 years had passed since Leland Stanford drove the golden spike at Promontory Summit, completing the Transcontinental Railroad. That ceremonial moment symbolized the unification of a continent, the triumph of industrial progress over wilderness. Locomotives now hauled cattle, grain, timber, and passengers across distances that once required months to traverse. Eastern factories shipped manufactured goods westward. Western raw materials flowed eastward. The railroad transformed American commerce and settlement patterns fundamentally, but the transformation remained incomplete. The Transcontinental Railroad was a single main line with limited branch connections. Vast territories across Wyoming, Montana, Colorado, New Mexico, Arizona, and Nevada lay 200 miles from the nearest depot. Ranches established in these remote areas during the land rush of the 1870s found themselves connected to national markets only theoretically. A rancher could ship cattle to Chicago, but only after driving them weeks across open range to reach a railhead. He could order tools and supplies from eastern manufacturers, but delivery required coordination with infrequent freight shipments, and costs were prohibitive. Iron tools, essential for ranch operations, exemplified the problem. In 1879, American iron production centered in Pennsylvania, Ohio, and Illinois. Pittsburgh's blast furnaces and rolling mills produced rails, structural iron, and tool steel. Cleveland and Chicago hosted foundries and machine shops that manufactured agricultural implements, hand tools, and hardware. These industrial centers supplied the nation, but distribution networks remained primitive. A hardware merchant in Cheyenne stocked tools shipped by rail from eastern suppliers. His inventory turned over slowly because demand was dispersed across hundreds of miles of ranchland. He couldn't afford to maintain large stocks of specialized items. When a rancher needed fence pliers, a specific size wrench, or replacement shovel blades, the merchant often had to order from suppliers, a process requiring weeks or months. Shipping costs added substantially to prices. A pair of fence cutters that cost $2 in Pittsburgh might cost $4 in Cheyenne after transportation, wholesaler markup, and retail margin. For ranchers operating on thin margins, waiting for cattle sales to generate cash, such expenses were significant. The daily reality of ranch work made tool shortages more than inconvenient. Fencing vast acreages required wire cutters, staple pullers, post-hole diggers, and hammers. These tools broke regularly under heavy use. Barbed wire, introduced commercially in 1874, revolutionized range management by making it economically feasible to fence large properties. But working with barbed wire was brutal on tools. Wire cutters dulled and cracked, hammers split handles, staple pullers bent under strain. A rancher managing 10,000 acres of grazing land might employ half a dozen cowboys during peak seasons. Each man needed basic tools. Breakage was constant. Without immediate replacements, Work stopped. A broken shovel meant fence posts couldn't be set. Broken pliers meant wire couldn't be cut or spliced. A damaged wagon wheel hub meant freight couldn't be hauled. In eastern states, a farmer could visit a nearby town and purchase replacements within hours. In Wyoming Territory in 1879, that option rarely existed. Self-sufficiency wasn't a philosophical choice for these ranchers and cowboys. It was necessity imposed by geography and economics. Men who worked isolated properties learned to repair equipment, improvise solutions, and make do with available materials. This practical ingenuity drew on skills many had learned before moving west. A significant portion of settlers in the Western Territories during the 1870s were immigrants or children of immigrants from Germany, Ireland, Scandinavia, and Britain. European agricultural traditions emphasized self-reliance and craft skills. A German farmer typically knew basic blacksmithing. An Irish laborer understood stonework and tool maintenance. Scandinavian immigrants brought woodworking and metalworking knowledge from regions where long winters and geographic isolation made self-sufficiency essential. These skills transferred directly to frontier conditions. The railroad itself, while failing to deliver manufactured goods efficiently to remote areas, inadvertently provided raw materials. Railroad construction and maintenance generated substantial waste. Wooden ties rotted and were replaced. Rails wore out and were upgraded. Most significantly, iron spikes used to fasten rails to ties were consumed in enormous quantities and frequently discarded. Each mile of track required approximately 400 spikes. The Transcontinental Railroad stretched nearly 2,000 miles, requiring roughly 800,000 spikes for initial construction. Maintenance, repairs, and branch line construction consumed millions more. Not every spike remained in service. Track crews drove spikes into ties, but would split. Spikes bent, rails shifted. Maintenance gangs pulled damaged spikes and drove fresh ones. The old spikes, bent or worn, were often left beside the tracks. Railroad companies saw no value in collecting and recycling them. Scrap iron had minimal value in remote locations where transportation costs exceeded material worth. So the spikes accumulated along rights of way, available to anyone willing to collect them. Similarly, chains used for securing cargo on flat cars, pulling equipment, or anchoring loads broke under stress and were abandoned. Broken chain links, metal straps, damaged tools left by construction crews, all became part of the industrial debris scattered along rail lines. For cowboys and ranchers, this debris represented opportunity. The materials were free, readily available, and suitable for repurposing. Railroad spikes were made of wrought iron, a material with excellent properties for forging. Wrought iron contains very low carbon content, making it tough, malleable, and resistant to fatigue. It welds easily when heated and hammered. These properties made it ideal for spikes, which had to withstand repeated hammer blows during installation and then hold rails firmly for years. The same properties made railroad spikes excellent raw material for forging tools. A 6-inch spike contained enough iron to make a knife blade, a chisel, a small hatchet head, or several fence staples. Chain links, typically wrought iron as well, could be separated, heated, and reshaped into hooks. Rings, hinges, or tool components. The process of transforming railroad spikes and chains into functional tools required knowledge, equipment, and skill, but the technology was ancient and widely understood. Blacksmithing dated back millennia. By the 19th century, basic metalworking skills were common in agricultural communities worldwide. A typical European village had a blacksmith who shod horses, repaired tools, and fabricated hardware. Immigrants from these communities brought that knowledge to America. On the frontier, where professional blacksmiths were scarce, men with even rudimentary metalworking experience became valuable. Many ranchers established small forges for shoeing horses and repairing equipment. These forges, though simple, were sufficient for more ambitious projects. A frontier forge consisted of a hearth, fuel, bellows, anvil, and basic tools. The hearth was often built from stones or bricks, forming a fire pit with a flat working surface. Fuel was typically charcoal, made by burning wood in oxygen-starved conditions to produce nearly pure carbon. Charcoal burned hotter than wood and produced less smoke, making it ideal for metalworking. In areas where coal was available, either mined locally or shipped by rail, it served as an alternative fuel. Coal burned even hotter than charcoal and was preferred for heavy forging work. Bellows, devices for forcing air into the fire to increase temperature, were essential. Leather or canvas bellows, operated by hand or foot, could raise forge temperatures to 1500 degrees Fahrenheit or higher, sufficient to make iron malleable. An anvil provided a hard, stable surface for hammering hot metal. True anvils, made of hardened steel with a flat face and various shaped edges, were expensive and heavy. Many frontier forges used substitutes. A large, flat stone could serve as an anvil for light work. A section of railroad rail, set vertically in the ground or mounted on a wooden base, provided a hard steel surface. Hardwood stumps, particularly oak or hickory, were dense enough to support hammering for shaping softer metals. Hammers ranged from small ball-peen hammers for detail work to heavy sledgehammers for moving large amounts of metal. Tongs held hot metal safely. Chisels and punches cut and pierced metal. A slack tub, a container of water or oil, was used for quenching, rapidly cooling metal to harden it. The forging process began with heating. A railroad spike was placed in the forge fire, buried in hot coals, and heated until it glowed red or orange, indicating a temperature between 1400 and 1600 degrees Fahrenheit. At this temperature, wrought iron became soft enough to shape but retained enough strength to resist deformation under its own weight. The smith removed the hot spike from the fire using tongs and placed it on the anvil. Hammering began immediately. Each blow deformed the metal slightly. Repeated blows, delivered with rhythm and precision, gradually shaped the spike into the desired form. To make a knife blade, the spike was heated and hammered flat, elongating the iron and thinning it into a blade shape. The smith worked carefully, maintaining even thickness and straight edges. As the metal cooled and became harder to work, it was returned to the forge, reheated, and hammered again. This cycle repeated until the blade reached the desired shape. The cutting edge was then refined by grinding or filing. Finally, the blade was hardened by heating it to critical temperature, approximately 1450 degrees, and then quenching it rapidly in water or oil. This process, called tempering, transformed the iron's internal structure, making the edge hard enough to hold sharpness, while keeping the body of the blade tough enough to resist breaking. To make fence staples, a spike was heated and hammered to flatten and elongated into a strip. The strip was then cut into appropriate lengths, each piece bent into a U shape, and the ends sharpened 2 points. A skilled smith could produce dozens of staples from a handful of spikes in an afternoon. To make, he hinges chain links, separated the weld joint until it softened, then pulling the link open. The opened link was reshaped, flattened, and holes were punched through it using a punch and hammer. To such pieces, connected by a pin, formed a simple hinge suitable for gates or doors. To make wrenches or pliers, multiple pieces of iron were shaped individually, then joined. Wrought iron welds, easily when heated to near melting temperature and hammered together. A smith could forge 2 pieces separately, heat them until nearly white-hot, place them together on the anvil, and hammer them into a single piece. This forge welding technique allowed construction of complex tools from simple components. The work required skill, but not extraordinary skill. A man with basic blacksmithing knowledge and practice could produce functional tools. The results weren't as refined as factory-made products, but they were durable and effective. Cowboys took pride in their forged tools. Some became known among their peers for particular skills, making knives, repairing bits and spurs, or fabricating specialized hardware. The range of items produced from railroad spikes and scrap iron was remarkable. Fence tools were most common because fencing was constant work. Wire cutters, essential for working with barbed wire, were forged by shaping 2 pieces of iron into jaws with cutting edges, then joining them with a pivot pin. Fence pliers combined cutting jaws with a hammer head and claw for pulling staples. Post hole diggers though more complex, could be fabricated by forging blades and attaching them to wooden handles. Blades of all kinds were popular projects. Knives were essential tools for cowboys, used for everything from cutting rope to butchering game. A forged knife from a railroad spike, properly tempered and sharpened, served as well as a purchased knife, and cost nothing but time and effort. Heads, shovel blades, and scraper blades were larger projects requiring more material and skill, but entirely feasible. Hardware items like hinges, latches, hooks, and rings were straightforward to forge and constantly needed. Gates required hinges and latches. Barns needed hooks for hanging tools and tack. Wagons needed rings for attaching chains and ropes. Buckles for harnesses, and straps could be forged from small pieces of iron. Repair tools were another category. Wrenches, though difficult to make with precise dimensions, could be forged in approximate sizes for common nuts and bolts. Pry bars, simple levers for moving heavy objects, were easily made by forging a spike into a long, flat bar with a curved end. Punches and chisels for metalworking and woodworking were straightforward projects, requiring only shaping and hardening. Specialized gear reflected individual needs. Branding irons, used to mark cattle with ranch symbols, were traditionally forged by blacksmiths. When a branding iron broke or wore out, a ranch blacksmith could repair it or forge a new one from available iron. Horseshoes could be modified or fabricated, though most ranchers purchased shoes in bulk when possible because the precision required for proper fit made forging them time-consuming. Wagon hardware, including brackets, braces, and fasteners, could be fabricated as needed to repair or modify vehicles. The craftsmanship involved in this work shouldn't be underestimated. These weren't crude improvisations. A well-forged tool, properly shaped and tempered, lasted for years. The iron in railroad spikes was high quality, manufactured to withstand enormous stresses. When repurposed and worked by skilled hands, it produced tools equal or superior to many factory products of the era. Factory-made tools in the 1870s varied widely in quality. Cheap tools were often made from inferior iron, poorly tempered, and prone to failure. A carefully forged tool made from a railroad spike, using good technique and proper heat treatment, could outlast cheaper factory alternatives. In the spring of 1881, a rancher named Thomas Durbin faced a crisis on his property in the Powder River Basin of Wyoming Territory. Durbin had purchased 5 miles of barbed wire fencing to enclose a section of grazing land before the summer season. The wire arrived on schedule, shipped by rail to the nearest depot, and then freighted by wagon to his ranch. But the shipment of fence staples, wire cutters, and stretchers that should have accompanied the wire failed to arrive. A freight company error had routed the tools to Montana Territory instead. Recovering them would take weeks. Durbin had hired 3 cowboys specifically for the fencing project, and they were ready to work. Delaying meant paying men to sit idle or sending them away and trying to rehire them later, which might prove impossible during the busy season. Durbin's ranch had a small forge used primarily for horseshoeing. One of his cowboys, a German immigrant named Klaus Becker, had apprenticed as a blacksmith in Bavaria before emigrating. Durbin explained the situation to Becker and asked if he could make the necessary tools. Becker walked down to the railroad tracks that passed 2 miles from the ranch house. He returned with a sack full of bent and discarded railroad spikes. Over the next 4 days, working from dawn until dark, Becker forged 300 fence staples, 2 pairs of wire cutters, and several stretcher hooks. The staples were slightly irregular compared to factory products, but they held wire firmly. The wire cutters, though heavier than store-bought tools, cut cleanly and proved more durable. The stretcher hooks, simple J-shaped pieces of iron, worked perfectly for tensioning wire. Durbin's crew completed the fencing project on schedule using entirely improvised hardware. The fence stood for more than a decade, and some of Becker's forged staples remained in place when the property changed hands in the 1890 A cattle drive from southeastern Montana Territory to the railhead at Miles City encountered disaster when a supply wagon broke, an axle bracket 70 miles from the nearest town. The wagon carried food, bedrolls, and equipment for 12 drovers moving 800 head of cattle. Without the wagon, the drive couldn't continue. The broken bracket was a metal piece that secured the axle to the wagon frame, subject to enormous stress on rough terrain. Replacing it required either fabricating a new bracket or abandoning the wagon and redistributing supplies among the riders, which was impractical given the amount of gear involved. The trail boss, a man named William Haskell, had passed a railroad siding about 5 miles back. He sent 2 men to investigate. They returned with several lengths of heavy chain, abandoned by a freight crew, and left rusting beside the tracks. Haskell had limited blacksmithing experience, but he understood the principles. The drovers built a temporary forge using stones gathered from a nearby creek bed. They fueled it with dried buffalo chips and sagebrush, which burned hot enough for their purposes. Using a flat rock as an anvil and a hammer from the wagon's toolkit, Haskell heated chain links until they glowed red. He hammered them flat, shaped them into brackets, and punched holes for bolts using a nail and the hammer. The work took an entire day. The resulting brackets were crude but functional. Haskell reinforced them with additional pieces and bolted everything together tightly. The wagon completed the drive without further failure. The improvised brackets held for the remainder of the season, and the wagon returned to the ranch intact. In the spring of 1885, the Box T ranch in the Texas Panhandle prepared for branding season. The ranch ran 3,000 head of cattle across 50,000 acres of leased grassland. Branding was essential for establishing ownership and preventing theft. The ranch owned 6 branding irons, each bearing the Box T mark. During the winter, mice had nested in the barn where the irons were stored. When cowboys retrieved the irons in March, they discovered that they had been severely damaged by rust and corrosion. The iron handles had weakened, and the brand faces had pitted and become uneven. Ordering replacement irons from a foundry in Fort Worth would take weeks and cost money the ranch couldn't spare before cattle sales generated revenue. The ranch employed a Mexican cowboy named Esteban Morales, whose father had been a blacksmith in Chihuahua. Morales examined the damaged irons and determined they could be repaired, but he needed additional iron for rebuilding the handles. He rode to the Fort Worth and Denver railway line that passed 15 miles from the ranch headquarters. Along the tracks, he collected 24 railroad spikes. Back at the ranch forge, Morales heated the damaged branding irons and cut away the rusted sections. He forged the railroad spikes into new handle sections, welded them to the existing brand faces, and refinished everything. The repaired irons were heavier than the originals but more durable. The ranch completed branding season on schedule, marking more than 800 calves. Morales's repaired irons remained in service for years, and he gained a reputation across neighboring ranches as a skilled metal worker. Other ranchers began bringing him damaged tools and equipment for repair, and he supplemented his cowboy wages with blacksmithing work. These stories, documented in ranch records, personal letters, and regional histories, illustrate a widespread practice. Forging tools from railroad materials wasn't an isolated phenomenon or a desperate measure used only in emergencies. It was a routine aspect of frontier life, a practical response to economic and logistical realities. The practice represented something deeper than mere survival. It embodied the self-reliant ethos that defined the American West during the late 19th century. Men who worked on the frontier took pride in their ability to solve problems independently, to improvise solutions, and to maintain operations despite obstacles. This attitude wasn't romantic individualism. It was pragmatic necessity elevated to cultural value. The duality of the practice is striking. Railroads symbolized industrial modernity, technological progress, and the integration of the American continent into a unified economic system. The Transcontinental Railroad was celebrated as a triumph of engineering and capital, a demonstration that American industry could overcome any obstacle. Yet the same railroads that represented this industrial future left behind materials that sustained pre-industrial craft traditions. Cowboys used the byproducts of the Industrial Revolution to maintain a way of life that predated industrialization. They took mass-produced iron spikes, manufactured in Eastern foundries using the latest metallurgical techniques, and reworked them using methods that hadn't changed fundamentally since the Middle Ages. This contradiction reflected the transitional nature of the era. The American West in the 1870s and 1880s existed simultaneously in multiple economic stages. Railroads and telegraph lines connected the region to global markets and information networks. Cattle ranching operated as a capitalist enterprise, driven by demand from Eastern and European markets. Yet the daily work of ranching relied on skills, tools, and methods that were essentially pre-industrial. A cowboy in 1880 might work for a ranch financed by British investors, drive cattle to a railhead for shipment to Chicago stockyards, and communicate with distant markets via telegraph. But he also forged his own tools, repaired his own equipment, and lived in conditions that differed little from those of medieval herdsmen. The economic independence that forging tools provided was significant. Ranchers who could fabricate and repair their own equipment reduced dependence on distant suppliers and expensive manufactured goods. This independence translated directly into cost savings and operational flexibility. A rancher who waited weeks for tools to arrive from Eastern suppliers lost productive time and incurred opportunity costs. A rancher who could forge replacement tools immediately maintained operations and controlled expenses. The difference, aggregated over years and across an entire ranch operation, was substantial. This parallel economy of repurposed materials and homemade equipment operated alongside the formal market economy. Cowboys collected scrap iron, forged tools, and traded or sold them to neighbors. A cowboy known for making good knives might trade them for other goods or services. A ranch with a skilled blacksmith might repair tools for neighboring ranchers in exchange for labor or supplies. These informal exchanges created economic value outside official channels and helped communities function. Despite their isolation from industrial centers, the cultural legacy of frontier blacksmithing extended well beyond its practical utility. The image of the self-sufficient cowboy, capable of solving any problem with ingenuity and hard work, became central to American mythology about the West. This mythology often obscured the harsh realities of frontier life, the violence, the exploitation, the environmental destruction, but it captured something real about the resourcefulness that isolation demanded. Stories of cowboys forging tools from railroad spikes became part of Western folklore, passed down through families and communities. Tools made by grandfathers or great-grandfathers were kept as heirlooms, tangible connections to frontier heritage. By the 1890s, conditions began changing. Railroad networks expanded significantly during that decade. Branch lines reached areas that had been isolated in the 1870s. Towns grew around railroad depots, and those towns supported merchants who stocked tools and supplies. The expansion of mail-order catalogs, particularly Sears, Roebuck and Company and Montgomery Ward, revolutionized retail distribution. By 1895, a rancher in Wyoming could order tools from a catalog and receive them within weeks via mail. Prices remained higher than in eastern cities, but the convenience and reliability improved dramatically. Manufactured tools became more affordable as industrial production scaled up and competition increased. Ranch economics changed as well. The open range era ended during the 1880s as fencing became universal and land ownership consolidated. Larger ranches, operating with more capital and better access to credit, could afford to stockpile tools and equipment. They purchased supplies in bulk during trips to regional centers or through catalog orders. The need for improvisation decreased as supply chains matured. Professional blacksmiths established shops in growing western towns. These smiths offered services that frontier forges couldn't match: precision work, specialized tools, and consistent quality. A rancher might still maintain a forge for emergency repairs and horseshoeing, but complex fabrication work was increasingly outsourced to professionals. Specialization replaced generalist self-sufficiency. As the frontier economy matured, individuals focused on their primary occupations rather than maintaining diverse skills. A cowboy in 1880 might need to be a competent blacksmith, carpenter, veterinarian, and cook. A cowboy in 1900 could specialize in livestock handling and rely on others for supporting services. This specialization increased efficiency, but reduced the individual autonomy that had characterized earlier frontier life. By 1910, forging tools from railroad materials had become rare. Older cowboys remembered the practice and occasionally demonstrated it to younger men, but it was no longer necessary. Manufactured tools were readily available, affordable, and superior in quality to improvised alternatives. The skills of frontier blacksmithing faded as the generation that had practiced them aged and died. Some knowledge was preserved in families where blacksmithing remained a trade, but the widespread competence in basic metalworking that had characterized the frontier generation disappeared. The practice of forging tools from railroad spikes represents a specific moment in American history when Old World craftsmanship intersected with New World industrialization. It demonstrates how technological change creates opportunities as well as disruptions. How the same forces that render old skills obsolete can also provide resources for their continued practice. It shows human ingenuity adapting to circumstances, finding solutions in unexpected places, and maintaining agency in the face of systemic limitations. Modern parallels exist. Contemporary makers and craftspeople have rediscovered traditional blacksmithing, often as a hobby or art form rather than economic necessity. Railroad spike knives, forged using the same techniques cowboys employed in the 1880s, are popular among bladesmiths and collectors. The appeal lies partly in the historical connection, the sense of participating in a tradition that links present to past. It also reflects a broader cultural interest in self-sufficiency, handmade goods, and traditional skills. In an era of mass production and global supply chains, the ability to make something with one's own hands from raw materials carries psychological and cultural value beyond mere utility. The enduring appeal of self-sufficiency, the desire to control one's own circumstances and not depend entirely on systems beyond individual control, resonates across different eras and contexts. The cowboys who forged tools from railroad spikes weren't making a philosophical statement about industrial society. They were solving immediate practical problems, but their solutions embodied principles that remain relevant: resourcefulness, adaptability, the refusal to accept limitations as permanent, and the confidence that problems can be solved through skill and effort. In 1879, when ranchers had no iron for tools, cowboys didn't wait for supply chains to catch up. They didn't petition railroad companies for better service or complain to territorial governments about infrastructure deficiencies. They looked at the resources available, assessed their own capabilities, and forged solutions from the broken remnants of progress itself. That spirit, the determination to turn obstacles into opportunities and scarcity into creativity, became part of the American character. Whether it was ever as universal as mythology suggests is debatable, but it existed genuinely in the experience of men who worked isolated ranches and faced daily challenges that required immediate solutions. The tools they forged were more than functional objects. They were expressions of autonomy, demonstrations of competence, and assertions of independence. Each knife blade hammered from a railroad spike, each fence staple bent from scrap iron, represented a small victory over distance, isolation, and economic constraint. Collectively, these small victories enabled the settlement and development of vast territories that would have remained wilderness without the determination of people willing to make do with what they had and create what they needed. That legacy, forged in frontier blacksmith shops and tempered by necessity, remains part of the historical foundation on which later prosperity was built. If you enjoyed discovering how cowboys turned railroad scraps into essential tools, subscribe to the channel for more untold stories from America's frontier. Hit that like button and drop a comment telling us what piece of Old West history you'd like to explore next.